Hi, this is Mrs. Kidman, and in this video, we're going to be talking about zeros of functions. So when we're talking about zeros of functions, the reason why we call them zeros is because what we're looking at here is we're looking at where is the function when y equals 0. So zeros are another way of saying our x-intercept. So whenever we see something that says find the zeros of f of x, equals x minus 1, x plus 2, find the zeros of the function. What we're talking about is if the function equaled 0, what are the two numbers, or what are the numbers that would make it equal 0? That's why it's called the zeros. So we talked about how to do this in a previous video when we talked about solving polynomial equations in factored form back in chapter 2. So when we are looking at solving equations, especially quadratics, and finding their zeros, really what we're doing is we're asking ourselves, what numbers do I have to substitute into this quadratic equation and get out the number 0? And the way that we do that is we are going to solve it just like we do in factored form. So here I'm looking at what are each of these two parts equal to 0. Now remember, in the previous video, we talked about that when I graph these, what these 2 points are is they're actually are x-intercepts. So that means I have an x-intercept here at 1, and I have one here at -2. And that 1 and -2, those x-intercepts, that's our zeros. So the way that we can figure those out is we do x minus 1 equals 0, and x plus 2 equals 0. We set each part equal to 0. The reason why is because by that zero product property, any number times 0 is 0. So we set them equal to 0, we solve for x, and we get x equals 1, and x equals -2, right? Those are 2 zeros there. So when we're talking about those zeros, again, those factors and zeros kind of go hand in hand. So for any factor, an x minus n is the 0 of the function. And that n is super special because it is also our x-intercept. Okay, that's what we're looking at. So we are just going to go through a couple of examples of how we find our zeros. Now, in the past, we were looking at problems where we were finding the zeros of functions when they were already factored. In this case, we're going to have to factor them first and then find those zeros. So let's take a look at this first one. This first one has 2 terms. There's no greatest common factor, so I'm going to factor it using my special product property, and I get x minus 4 times x plus 4 equals h of x. Now, if I want to find 0, remember, I'm going to take this h of x and I'm going to set it equal to 0. So 0 equals x minus 4 and x plus 4. So what x values will make this statement true? Well, those x values are going to be x equals 4 and x equals -4. And again, those zeros are also our x-intercepts. So that means when I graph this function, it is going to cross at a +4 and at a -4. The rest of our function will look as it does, but that is where our function is going to cross there, is at those 2 points. That's our zeros. So let's take a look at this next one. On this one, if we want to find the zeros of the function, we also have to factor. Remember, when we're factoring, our first rule is our GCF. Our second rule is to count our terms. And then our last one is to make sure that we factor completely. And so we all thought we were done with this factoring, but really, we're going to keep seeing it. So I'm going to factor out what's in common here. I'm going to factor out a -2. So f of x equals -2 times x squared plus 5x plus 6. Now I want to factor this x squared plus 5x plus 6. We always want to factor when we're finding the zeros. We always want to factor out whatever this number is here. Factor that out so I get an x squared. And the reason why is because then it makes it easier when I factor. So I'm going to factor using my x method, and I want 2 numbers that multiply to 6 and add to 5. Well, those 2 numbers are 2 and 3. So when we factor this, I get a -2 times x plus 2 times x plus 3. And that's our f of x. So I want to find my zeros. So I'm going to set it, again, equal to 0. So 0 equals -2 times x plus 2 times x plus 3. Now this -2 isn't going to do anything. All that -2 does is it affects our shrink and stretch. This right here is in our factored form, correct? So here we have factored form. And so our zeros are just going to be these 2 pieces. So that means that x equals -2 and x equals -3. and those are the 2 zeros, just like we've been finding. So as we're finding those zeros of those functions, that's all we're going to do. Sometimes it gives it to us in factored form, and we know what those numbers are. Sometimes we're going to have to factor it ourselves. And when we factor it, make sure that you're factoring it following these steps. Find your greatest common factor, then count our terms. Remember, if I have 2 terms, I'm going to use that special product property. If I have 3 terms, then I'm going to use my X method. If there are 4 terms by chance, then I am going to use factor by grouping. If for some reason it is already factored, like this one, we do not need to factor it again. So do not factor it. And then once we've counted our terms and factor, make sure that we have factored completely. So I want to go through all 3 of these problems because we know how to factor and we kind of know how to find those zeros and we've practiced it before. I want you to do these ones on your own. So go through problems 4, 5, and 6 on your own. After you've finished going through all 3 of those problems, unpause your video and wait for those solutions to come up. As soon as those solutions come up, check with your answers. See if you got the same thing I did. If you did, awesome. If not, check to see either where my mistake is or check to see where your mistake is. And as you have questions, feel free to reach out and we can go over them together. So go ahead and pause your video and take a second to answer these questions. Okay, hopefully you've had a chance to go over these problems. Now, in this first one, it was already factored. So this is already in our factored form. So I did not have to factor it. And remember, it's going to equal whatever this number that's subtracted is. So x equals 6 here and x equals 1. Awesome, those are our zeros. So again, that means if I were to graph this, I would have something here and something out here. And my function is going to look something like this. Now, in this next one, when we factored it, I looked for greatest common factor. That was 1. Then I counted my terms. I had 2 terms, so I had to use my special product method to factor this. And it factored out into x plus 1 and x minus 1. So our zeros of our function are positive 1 and negative 1. So what that means is when we graph this, which is what makes sense, we have a point here at positive 1, a point here at negative 1, and it's going to look just like this. Okay, and we know that based on those 2 points. This last one here is extra special, 3x squared minus 12x plus 12. So what this one tells us is as we factored out, there is a greatest common factor and that number is 3. And then we want to factor the remaining polynomial using our x method. So I factor that trinomial and I get 3 equals x minus 2 times x minus 2. Now notice how both of these are x minus 2. So we actually only have one solution here, and that solution is going to be when x equals 2. So what that tells us about our function is that when I graph this equation, what's going to happen is it's only going to cross my x-axis one time, and that place it's going to cross is going to be at x equals 2. And so our function, whatever it looks like, is going to end up looking something like this, where it only crosses once and it's going to cross right there at x equals 2. And that is how we find the zeros of a function. We set the function equal to 0, we factor it if it's not factored, and then figure out what x values will make it equal 0. And that is how you find the zeros. And a reminder, our zeros are another term for our x-intercepts. So this is telling us where it crosses the x-axis on our graph.